we'll be covering some global settings, then jumping into signalized control, and then covering stop controlled intersections. Then we'll move into some scenario management capabilities of Vistro, and then finishing it off with roundabouts and our reporting capabilities. So let's get started in the software itself. So I'm going to start, we have, again, this sample file. If you attended our last webinar, you'll know that we built up this file from scratch, kind of with going through some of the intersection setups and volumes tabs, and then a little bit about traffic control. But today we're really going to get into the weeds of the traffic control side. But before we get started on this part, let's first jump up into the edit menu. And in the edit menu, we have this global settings menu. We didn't cover this in great detail in the last webinar. So in this webinar, we're just going to kind of take a look at it. This menu is where all of the global defaults are kept in Vistro. And in Vistro, we don't want these global defaults to be hidden or in the black box. You can kind of edit these ahead of time before you get started on your network, so that when you insert new intersections, these are the default settings that you'll go through. A few of the default settings that that you should pay attention to are, or that we'll point out here, are the left-hand versus right-hand traffic. Vistro has the capability to do both. The units, we can either do imperial or metric. We have various different analysis methods for the different intersection types. And so again, you can set your defaults here. We have a few different HCM versions. We have CCG, Circular 212 for the signalized intersections. For roundabouts, we have Kimber and HCM 2010. And then for unsignalized intersections, we have 3 different HCMs. These are all also editable at a local level. So we can change these at the specific intersection itself. And then we have some other parameters that apply specifically to different tabs, but I'm going to jump down to here. We have a couple, like located in the central business district. By default, is this on or off? We also have a search option up in the top, so if you're having trouble finding a specific parameter, such as central business district, you can just type it into the search up at the top, and then you can easily find that parameter. A couple more parameters I wanted to point out were the major flow signal groups. Since we'll be talking about signal timing, I just wanted to point out that our major flow signal groups we have by default are based on the NEMA standard, but if you're not using that standard, or yours is maybe a little bit different, you can always change what your major flow signal group numbers are. And then finally, your approach directions. We have 2 options here: prefer main directions or use main and secondary directions. This is in reference to, if we look here on this intersection, the label of these approaches, whether they are northbound and southbound, or sometimes you might have like a northwest or a southeast bound or something like that. If you want the northeast and southeast bounds, then you will use the prefer or use main and secondary directions. Otherwise, it will kind of round out each one of those to just north, south, east, west. All right, so that is the global settings. Again, I'm not going to go through all of these parameters, but just hit some of the highlighted ones here. And again, you'll set these before you start building, so that it will apply to your new intersections. And then you can change these locally as needed. Okay, so let's get started on actually updating some of our, or one of our intersections control types. So here I have already set up the physical geometry of this intersection. Let me zoom in a little bit. We've already configured the physical geometry of the intersection. We've already put in some of the demand for this intersection, and now we are configuring the traffic control. So starting up at the top, we are going to look at this priority scheme. Here we need to define our major flow in our minor flows. Now, from our global settings, if we go back to the global settings real quick, the default major flow direction was defined as north-south, but for this particular intersection, the major flow is east-west. So I need to switch my major flow on my north and southbound to minor, and then it'll automatically switch my east and westbound to major. So now my major flows are my east and my west. Moving on, the located in central business district. Again, if we look at our global settings, by default, this was checked as on, here we go, CBD. This was checked as on, but we don't want this model to be in the central business district. This model has already been checked off, but if we wanted to apply this change globally to all of these intersections, so we make sure that none of them are in the central business district, but we've already built our model, we will use the MultiChange feature. So similar to our global settings, we have this MultiChange option in our edit menu. This allows us to edit many of our attributes on a global scale after we've built the model. So here in the edit menu, we'll find edit, MultiChange. And then I have this attribute selection here. So I can find the attribute I want. Here we have central business district. I can set the attribute value to false. So I don't want to turn off this located in central business district. And then down here, we have a list of all of our intersections in our network. We can use some filter features to filter the list. So for example, if I only wanted to affect all of my signalized intersections, I could use this filter option under the control type to signalized, and then uncheck that for all of those intersections. So again, you'll go up into the edit menu, find the MultiChange option, select your attribute, define what you want to do to the attribute, and then you will select which intersections you want this to apply to, and then you'll select the apply button. Here, nothing was changed because this had already been done, but if I were to select true, for example, and say apply to all these, it was applied to 8 intersections. So again, I can hit false and hit apply, and you can see what had been changed. Okay, so that was the MultiChange option. Here we have, we've edited the priority scheme. We've turned it off from being in the central business district. Next, we're going to look at the cycle length. So here I'm going to set my cycle length to 120 seconds. We have coordination type. Under coordination type, we have a few different coordination types. We have time of day coordinated, time of day isolated, and free running. I'm going to set this one to time of day coordinated. Next, we have the actuation type. I'm going to set it to semi-actuated, but we also have a fixed time and fully actuated option, depending on your level of actuation. I'm going to set an offset of 17 seconds. And then I'm going to leave my offset reference as leading green, but just so you guys can see, here are all the different types of offset references we have. So there's various places that your offset can be within a cycle, and Vistro accounts for pretty much all of them there. Similarly, we have different permissive modes. If you're going with an actuated controller, we're going to leave it on single band, but we also have multi-band and reservice options. Okay, getting down into the timing. The first thing you're going to want to do when setting up the timing of your controller, after you've done kind of the intersection settings, the intersection coordination groups and cycle lengths and things like that. When we get down to the individual movements, now we're going to want to define our signal groups. In this case, at this intersection, we're going to have protected lefts on all approaches. And you can see that by default, these are selected as permissive. And so the column is grayed out because it'll just link the timing with the associated through movement. Here, though, I'm switching it over to protected so that it activates that left turn phase capability. Similarly, I won't be doing it on this intersection, but for the right turn, you can also activate overlaps if you wanted to, and that will open up the right turn column for your overlap phases. So going off of the NEMA standard, our major flow is east and west. So that means that our eastbound is going to be 2, our westbound is going to be 6, our northbound is going to be 8, and our southbound is going to be 4. And you can see it's when I type in a phase number here, it is auto-populating this column with these values from our global settings. So again, we can come through and edit those later, but it is auto-populating. So if there's any important things like our amber or all red times that you want to apply to all phases in your network, you do that in the global settings ahead of time. Now I need to add my left turn phases. So again, just following the NEMA standard. Here we have 3 associated with 8, 7 with 4, 5 with 2, 1 with 6. Now I'm using the NEMA standard phasing, but you do not by any means have to use this. If your phasing looks a little different at your local intersection, you can put it in however you want there. After you've entered your signal groups, I'm going to get into this timing in a second, but next you'll want to add it to your sequencing. So here we'll define our rings and our barriers. And you can see that there's plenty of room to add in a lot of signal groups per ring, and as well as we have up to 4 rings. So here I'm just going to, again, just by default, add my signal groups 1, 2, 3, 4 in ring 1, 5, 6, 7, and 8 in ring 2. You'll notice that it's putting both the left turns ahead of both of the through movements, and that's because these phases 1 and 3 have been set to leading, and I haven't set a barrier yet. So how you set a barrier is you just hover over this gray bar that separates the 2 cells, and you just left click on it one time and it'll add a barrier. And you can see that it'll automatically snap these into the appropriate barrier group as well. Now what I'm going to do is I'm going to go through and I'm going to edit the split timing. So here I'm just going to quickly do this. I can edit the split timing here, 19 seconds. I want phase 2 to be 39 seconds. Phase 3 to be 22 seconds. Phase 4 to be 40 seconds. Phase 5 to be 20 seconds. Phase 6 to be 38 seconds. And you can see that the timing plan below is automatically updating as well as I'm doing this. 16 seconds and 46 seconds. So here we go. We've added our split timings here in this column or in this row directly. Or what I could have done instead was just left click and drag on the green bars, and I can actually adjust the timing directly on the sequence down below. I can do the same thing with the pedestrian phases. So I can grab with a left click, I can grab and drag the pedestrian phases here. One thing I want to do is I want to adjust my amber timings to be 4 seconds across the board. So I'm just going to left click and drag and highlight all of my amber, and then I'm going to say 4 seconds and then hit enter. So again, I just left click and drag the whole row, and you see this multi-edit comes up, and I can type in whatever value I want and then hit enter, and that will apply that value to all of the selected cells. Once you have your cycle length and your splits entered and your sequence entered, now I would go into the specifics and check boxes like which are my coordinated groups, what kind of recalls do I have, where do I have detectors, things like that. What are my minimum green timings and maximum green timings? If you have exclusive pedestrian phases or ped scramble phases, as they're sometimes referred to, you can also enter a ped scramble phase here. So that way it will tack on a phase at the end. So you would enter the signal group here and then put it into the sequence. All right. So before I move on, what I'm going to do is I'm going to jump down. I have this identical intersection down below. And what I want to do with this intersection, oh, it looks like I left the timing. But what I was going to do with this one was show that we have this create default signalization button here. So if you select this create default signalization button, it will take the signalization, and based on the major and minor flows, it will assign the signal groups to it. It will also create the sequencing here and run a quick optimization to give you your splits, so that way you have a good starting point, and then you can go back and edit the actual the specifics of your intersection afterwards. So if you're editing a lot of intersections, or you are going through this pretty quickly, you can always just go select the intersection, and once you have your demand placed, you can just click this create default signalization and click OK, and it will build out the standard NEMA phasing for you. Okay, so once you have all of your signal timing in place, you'll go on to do the analysis. And for that, I'm going to hand it over to Bill. But
calling an audible here, I'll begin at the last part of what Levi was showing. Essentially, I want to show you guys if indeed you went to that other intersection, and rather than having to input all of the NEMA numbering or signal group numbering or phase numbering, whatever you'd like to call it, that you can, as long as you have all of your lane configurations in and volume data and have set the things on the intersection settings level and gone ahead and coded your protected lefts or any modifications to the rights that you might have had, and opened up the signal group indicators here, rather than needing to manually go in and insert the phase numbers, you can go ahead and take advantage of our create default signalization as Levi described. But just to show it visually, if I click that button, it asks me one more question, which is, do I want to have leading or lagging lefts? And then once I select OK from that, then we can see that it goes ahead and automatically fills those signal group numbers and puts them into sequence automatically. Of course, I can always change it after the fact if indeed I need to do so. But it's a big time saver. Also, just to mention, we had mentioned it during the first webinar, but if you have a corridor, east-west corridor, let's say like this, where many of your phasings may be similar, you may decide to copy your intersection and paste it down after you complete your timing for the first intersection. It really just depends what workflow becomes most efficient for you. So with, just wanted to highlight that. Now what I'd like to do is go back to our primary network here. Sorry, bear with me 1 second. And let's go into that intersection. And let's look at some of the calculations. So after you're through with the inputs, this is the first tab, workflow tab, after the intersection setup, volumes, and the traffic control. It's the first time where we really start to see calculations from our analysis. Just to re-emphasize what Levi had shown in the global settings, you can select a variety of calculation methods for signalized intersections. Defaults to the HCM 6th edition. We do have the 2010-2000 Canadian Capacity Guide and also some planning level methods as well. So looking at the 6th edition calculations, if I scroll down, then you will get to the part after the exclusive PED phase. There's another sub workflow table that's called lane group calculations, and here's where you'll begin to start to see some of the calculated values. In this case, a reminder that in Vistro all of our italicized cells represent calculated values, Here we can start to see where our green start and end times are, what our actual green time and effective green times would be in our green per cycle. And any of these subtables, again, you can click on the little arrow next to them if I want to minimize the view. It's kind of like hiding rows in Excel, just to be able to quickly get to the next portion. So the next step would be reviewing what Vistro does from an HCM perspective for saturation flow rate calculations. So if you remember back to the highway capacity manual, that begins with the base saturation flow rate, which defaults to about 1,900 passenger cars per lane per hour of green. And then it applies a number of saturation flow adjustment factors for things like lane width or heavy vehicles and grade, presence of on-street parking or bus blocking within 250 feet of the signal and so forth. Those inputs were done back on the intersection setup screen primarily, or the volume screen for the case of the heavy vehicle percentages. But back in those screens, we entered how wide our lanes were and so forth. And so then it will pull that information in and show us what our saturation flow adjustment factor calculations would be in these cells here. One of the things that area type is where the CBD button comes into play. It would do a 10% reduction in saturation flow if we were in a CBD. And then lane utilization adjustment, that's where, if you have multiple lanes on an approach, so for instance, this eastbound through has multiple lanes, the way that by default, the HCM would not exactly divide the number of vehicles by exactly the number of lanes. There's a slight adjustment factor built in to account for some random assignment to the different lanes. But what we do allow in Vistro is the user to have a few points where you can override the default calculation. So one case may be the lane utilization. I like to use an example of special cases. This is not a freeway on-ramp, but sometimes if you have a freeway on-ramp, vehicles start pre-positioning themselves ahead of time. Actually, it would be more like the downstream intersection. If this were a freeway on-ramp, my through movements at the upstream signal may already begin to pre-position to show more of my throughs in the rightmost lane. And then I might want to account for that in terms of manually adjusting my lane utilization factor, which I would be able to do by simply clicking the box and then entering in, let's say, a different value like 0.8. That would give me a reduction in my overall sat flow for that movement group, for instance. Otherwise, I can leave that unchecked and use the HCM default calculation. There's a few other saturation flow rate adjustments that occur, again, based on the different inputs that we've already put into the software. I did want to highlight a few new ones that are part of the Highway Capacity Manual 6th edition. One is handling work zones. So if you do have work zones that you want to account for, you can check that particular approach is a work zone approach, and how many lanes are open in the work zone. So that may be something that you are analyzing. Also some other things like sustained build back or downstream adjustments that we can allow you to enter those factors as well. Ultimately though, after the long series of adjustment factors to that 1900 value, you will get a lane group saturation flow rate, which is basically the number of lanes times the ideal saturation flow rate times all of these adjustments. And also the GORC comes into effect there. But basically, you'll get this number per lane group. And there may be some of you that still do field calculations of saturation flow rates instead of just using the calculations out of the HCM. No problem if that's the case. You can go ahead and hardwire in your field observation. So for instance, let's say we did go out and do a sat flow study for that eastbound through lane group, and instead of 3503, we measured that there were actually, let's say 3,700 vehicles that for the saturation flow. I can go in and manually override that. So we do have the ability to do those type of flexibilities. It's also a bit more rare, but there are some jurisdictions out there who preset this base flow rate and then still want all of the calculations to be applied. We allow you to check a box to change the ideal sat flow rate and then still apply the adjustment factors. So it's very flexible in terms of the modifications that you can make. None of it, all of it still is true to what the HCM does, which is to apply a series of adjustment factors. or true to the fact that it's always best if you have local field conditions. So if you're going out there and doing a saturation flow rate study, that's going to give you more accurate information than using national averages anyway. So it's just a lot more tedious work, and most of the time there's not time or budget to do so. But if you do, we can handle that within the software. From there, if you continue to scroll down now to the capacity analysis section, then what you'll start to see are additional calculations, such as, again, showing your G over Cs, but now you'll start to see your V over Cs, volume to capacity ratios, as well as your different delay calculations. If you remember, HCM has 3 of those. One is a uniform delay, which is the bulk of the delay. Basically, it's to represent the presence of the signal, or what used to be a stopped delay, Webster's delay type equation. If any of those ring a bell from back in school, that's D1. D2 has to do with different randomness that occurs cycle to cycle, and small periods of oversaturation. And so there's adjustments that go on there that include like delay calibration and upstream filtering and so forth. That'll give you the second term. And then the third term, while we don't, it's a rarer occurrence where you have multi-period delays occurring, then you can go ahead and account for that in Vistro as well. And ultimately, you'll come down to your results for both lane groups and movements, approaches, and intersections as a whole. And these will look familiar to you all in terms of V over Cs, delays, levels of service, and then queuing is important to know here. We do the queuing calculations from HCM. It's called a back of queue method. We report the 50th and the 95th percentile queue lengths, both in the vehicles per lane and also the feet per lane. And those values are available as a result, MOE, as well as the delay, V over Cs, and the levels of service grades. And you can see on screen here that I've started to show some of these, my turn volumes, and then my movement levels of service. I can also post things like my overall intersection conditions, delay, level of service, and V over C. And you can see these are color-coded based on the severity. It would be green if it was A or B, for instance, and then we start to see yellow, orange, and red based on how severe the level of service occurs. All right, well, with that, what I'd like to do now also just to give a little precursor, we have other modes. We're not talking about them today, so I'm gonna hide them, but I do want you to know that we do have the pedestrian and bicycle measures of effectiveness calculations, and we're gonna cover that in a future PTV Talks session where we'll go into that from a multimodal analysis perspective. All right, I'm going to now turn off some of these so that I can see my screen a little better. And we're going to quickly look at two-way stop control. And here, again, we set these intersections up in our previous webinar, but we're going to now come in and focus on the traffic control table for this two-way stop intersection. This is a T intersection with a southbound leg that's controlled with a shared left or through. If I needed to change which legs are controlled, I go to the priority scheme button and I can change it from free to stop. And in this case, I have it correctly, and we can see it here on the screen that it's on the right leg. And we could go through in a normal, kind of a typical case and see all of our HCM results, but there's a couple unique, well, maybe not unique, but somewhat uncommon, but definitely occur things geometrically that can affect the intersection capacity and operations at two-way stop intersections. Those have to do with whether you have a flared lane approach or if you have what's called a two-stage gap acceptance. Here for the southbound, you can kind of see it in the aerial below our network that as the single lane approach actually comes to the stop bar, it flares out a little bit. So while officially striped as a single shared left-right lane, it does flare sufficiently enough that another right turning vehicle could saddle up side by side with a left turner that's waiting. So here we can handle that in Vistro by checking the box that says flared lane. And once that box is checked, I can enter my storage area in terms of number of vehicles. Typically, I would measure back and look for appropriate width and a distance where how many vehicles could store in that flared area. In this case, it's 1, so I can enter that. And the second thing that can occur is something called two-stage gap acceptance. And in cases where you may have an acceleration lane or even a center two-way left turn lane that allows the left turning vehicle to make the first movement, which is to cross the near side traffic and then come into the refuge area and wait until it can complete the rest of its movement. That can be done in 2 stages rather than the typical single stage. That has to occur at a two-way stop. So here I can check my 2-stage gap acceptance box. And while this lane may be a bit longer and I could store 2-3 vehicles in it, in real operations, it's typically rare to have more than 1 vehicle stored out there. These vehicles will be hesitant to come out until that vehicle clears, or driving behavior. Many times people stop right here instead of continuing down. So I'm gonna conservatively say there's 1 storage space in the median. And then once I do that, we'll look at the rest of our HCM results. There's not as many to see here in the two-way stop method, but it is a gap acceptance methodology. And so there's 2 things. One's called a critical headway. What's the critical or minimum headway that those vehicles would accept in order to complete their movement? And those are HCM calculations, defaults, and adjustments. We do, however, allow you to override that calculated critical headway by checking this box. And again, the purpose of that is if you were doing your own study at your own location, and let's say your traffic has much different characteristics than the national average, and maybe that you have more aggressive drivers or more conservative drivers, you can handle that through doing your own study and modifying it within Vistro. And also there's a concept called follow-up time, which is how many vehicles can be served during the same gap in the cross-street traffic. And there's an HCM default set of calculations that we provide. But again, if I have more aggressive drivers and more conservative drivers, I can modify that to reflect local conditions. And once I go through all of those calculations, I will again see V over Cs, delays, and levels of service, as well as a 95th percentile queue length for that approach. All right, with the two-way stop complete, I'll go ahead and move over to all-way stop. And there's not a whole lot for us to discuss, and there's a lot of interesting calculations that occur at all-way stops, and it's quite an iterative process behind the scenes and a perfect application for any type of software, because there's not a whole lot of inputs that we need, and it'll crank through all of those iterations to determine things like the different adjustment factors for headway and utilization. And really, the all-way stop method just briefly gets more and more complex with how many legs are on the approaches and then how many movements at each leg in terms of how the operations occur. In terms of reviewing the software results, you can see all of the adjustments, all the intermediate and final calculations. And then you can see the delays and queuing and level of service. And it'll tell you whether it converged through those iterations and how long that took. So that's kind of a quick view of the all-way stop, two-way stop, and signalized HCM calculations in this case. So with that, I'd like to do a brief introduction to our scenario management tool. This will be something that we're covering for the first time now, but we will continue to use throughout the remainder of our Vistro webinar series, because it becomes integral to typical workflows and really shows the strength and power of the software. So with that, we'll change gears a little bit, but I want to draw your attention up to the top of the software. There's this white box that says base scenario. And if I go ahead and click on the arrow to show me what scenarios are my network, I see that currently I only have the base scenario. And that's every time you start a Vistro project, it will default to something called base scenario. You can essentially input everything up until the point that you've completed one particular time period of analysis, say an existing PM, under this scenario. And then at that point in time, typically we have a need to analyze different things. It may be to analyze other time periods under existing conditions, like existing AM or maybe midday. And then there may be times where we're looking at some future volume increases and or some future network modifications, and or even things like what type of project might determine what type of scenarios you use. So you may have project scenarios that involve restriping or widening or retiming, or you may have scenarios that involve adding new trips to your network because there's a development that you're analyzing the potential effects of, like a new Home Depot or something of the sort. Any rate, so what you would do in your scenario manager here is begin by clicking this plus button. And when I do that, it takes everything that I've done so far in my base scenario. You'll see it defaults to this new scenario 1 Vistro scenario. I'll open this box up and I'm going to right click in the bar and rename it. And I'm going to name this existing PM and hit enter. And now it becomes really key for me to make sure that I'm looking in this white box to make sure that's my active and current scenario, because anything, whatever scenario is shown in the white box, any modifications I make will only affect that scenario, with one big exception, which is if I were to go back to the base scenario and make that active, that's a super scenario. It's a powerful scenario. If I make a change back in base, it'll follow through and update all of my other defined scenarios, just as an FYI. All right, so with that, after I have an existing PM, because that is what I did on my base, I don't really need to modify it. But let's say I have a future scenario for PM 2022. I would come to my existing PM. There's a down arrow. If I hover over that, it tells me that will duplicate the scenario. I'm gonna go ahead and click that button. You'll see that duplicates it. It gives me scenario 2, copy of existing. I'm gonna rename that and I'm gonna call that year 2022 PM and hit enter. And now what's critical, if I want to edit that scenario, is that I first left click it to select it. And I make sure that that scenario name is in my white box. That way I know for sure that that is the scenario that I'm going to be editing. Just briefly, one common thing would be to reflect some increased volumes. So if I go back to my volume tab, I can see that my base volume, I did not have any growth factor, which makes sense because I was using my count data. For 2022, say this is an area with moderate growth, 3% per year, I may want this growth factor to increase to 1.06 to represent 2 years of growth. We can, to your heart's content, do that out to 4 decimal places if you want. I could either come in and modify each of these individually or intersection by intersection, but this is a great use of our MultiChange feature. So if I go to edit MultiChange, and in this time go to attribute and select growth factor, I can enter my value that I want that to be, 1.06. And again, as Levi showed, I could sub-select certain intersections to apply that to, or, and then just pick certain intersections or filter it. But in this case, I want to apply it to every single intersection only in this scenario. So I click the apply button. It tells me that 147 movements in my network were updated. I'll hit close. And now I can see that growth factor here is turned into 1.06. In this particular case, that's all I'm going to do to differentiate year 2022 from existing conditions. But what I also want to do is show you an example of changing a network element in the scenario manager. So the next thing I'm going to do, and we have not talked about roundabouts yet, is I'm going to come in and I'm going to say we're going to have a build scenario where we convert this always stop into a roundabout. So I'll come here to my scenario manager again, click the button to get this window. I'll go over to year 2022 PM because I want to still apply the growth factors to this new scenario. I'll duplicate that. And then I'll rename that to something like year 2022 with roundabout, or I could just call it build or whatever might be the case if I have multiple changes. Again, I need to make sure that I left click to select that scenario and make sure that that's active in the white box. Just get in that habit so you're editing things in the correct scenario. Here, just for this scenario, it will currently show me as an always stop, but I can go into any of these tabs really. I'm just gonna go to traffic control, go to control type, and where it says always stop, I'm gonna turn that into a roundabout. And we'll see the roundabout here. Levi is going to edit this roundabout momentarily. Do that.
So as Bill had done previously, we built out a new build scenario. And so what we are going to do is we're going to edit this roundabout. Now, we're running a little short on time, so I'm not going to go through each one of these physical geometry changes in great detail. But going through kind of the story of this roundabout, what we might do is by switching it to a roundabout, we realize that our level of service is all really good and things like that. Our MOEs are showing really well. So we don't actually need 2 through lanes in many directions. And so we could repurpose those lanes into something like a bike lane. So what I'm going to do is I'm going to, as part of the build, I'm going to reconfigure the lane groups for my east, west, and southbound so that it reflects that change. And then my southbound as well will just become an all-way. There we go. Now you'll notice that since I removed these lanes, it left the 2 outbound lanes. So if you have an extra outbound lane, you could just right-click on the leg, and there's a little handle on the end of the leg that typically you'd grab this to adjust the geometry. But if you right-click on that handle, you can say remove through lane. And so now it just shows just the one outbound lane. And again, we might be repurposing this lane as something like a bike lane because it's not really going to significantly hinder our roundabout's performance. Some other geometric changes that you might consider are, as far as roundabout, that you'll see that are specific to a roundabout in Vistro are things like the inscribed circle diameter, the number of circulating lanes, if you have any sort of flared lanes or anything like that, bypass lanes, you can always add in a bypass lane as well. This particular roundabout won't need that, but these are some of the adjustments that you can make: the circulating roadway width and circulation speed. This is a fairly small roundabout, so we might drop the speed of this down to something like maybe 12 or 15 miles per hour, as opposed to closer to 20 miles an hour. So again, you'll come in, you can switch, as Bill showed, you can switch the control type just in any one of these tabs up in the summary section. You'll notice the first, again, like 11 rows or so are identical in each one of these workflow tabs. And then in the roundabout, you'll reconfigure some of the geometry here. And then looking at the traffic control tab, there's not a lot in the intersection settings. Again, we can see this number of circulating lanes. If I were to change this on either one of these pages, it would show up. So I can make this edit again, either on the geometry change or here. And then it goes through, in this case, we're using HCM 6 edition. You can go through and look again at your volume to capacity ratios. You can have your overrides, as Bill described earlier. We also have HCM 2010 and Kimber method as well, depending on how you are choosing to analyze your roundabout. Okay, so now that we have our, we've configured our signal, we've configured our 2-way stop, we've configured an all-way stop, and we've configured a roundabout. Now we want to report on our scenario 3, our new build scenario. So let's take a quick look at the reporting functionality in Vistro. Again, for the sake of time, I'm going to kind of go through this a little bit more quickly, but we'll go to File and then Print Report. Make sure you are in the correct scenario that you want to print the report from. So in this case, I want to print the report from scenario 3. I'm going to go to File, Print Report. And in the report printing, the first tab is where we can configure our report. So here we have some headers and footers that we can put. So for example, if you want to change the position of something like the scenario, or you can just drag it to a different position on the page. You can put in a company logo. You can put in your investigator name and then just type in, Levi Button here. And so you can configure your headers and your footers. We have different file formats. We have PDF output as well as HTML or CSV, depending on what you want to do with this report after. And you can also change the starting page number. So if this is going into a larger report, or maybe you've printed off scenario 1 and 2, this might be starting at page 17. That way you can just link them together. Now we've looked at how you can format the page. Next, we'll look at what reports we can print off. So we'll select the specific types of data and graphics that we want to put into the report. In this case, we didn't do any traffic impact analysis or signal optimization. Those are for future webinars, but here we've activated the signal warrants report, turning movement volumes and summaries, the table of contents. And then on the graphics side, we'll have a graphic of the study intersections, lane configurations, traffic volumes, and traffic conditions. And then finally, I'm going to select which intersections I want to report. So in this case, we have a roundabout, a two-way stop, and we can configure our signal warrants here. We have our traffic, and then our signalized intersections here. So again, you'll go up to File, Print Report, you'll configure your page, you'll select which reports and graphics you want to include in that report, and then you'll select which intersections you want to include in the report. That way, if you have some dummy intersections or something like that, you won't necessarily need to include those. Lastly, I'm going to make sure I have this open report after print, and then I'm going to hit the print option, and it will generate the report. So you can see it's thinking here pretty quick. And then once it's done, it's generated this PDF document of the report. And we have a fully active table of contents, so you can just select the options you want here. It also, if you're using Adobe, for example, you have this interactive ribbon on the side, so you can just pick, okay, which report do I want to look at for different intersections. I can go to my signal warrants here and look at my signal warrants for my two-way stop, for example. And then looking at some of the graphics, we have a graphic of our study intersections, as well as, so here's a map of our network with the intersection ID numbers. We have different lane configurations, again, with the map of our network, as well as the control types. We have the base volume inputs, and we have traffic conditions as well. So it's, again, showing you the map with some of your key MOEs that you're outputting for the intersections. If you want more information, you can go to the specific intersection and look at the intersection setup, or you can look at the turning movement volume summaries, and I'll show you specifically the turn by turn there. You can look at the detailed, so it'll give you more of the information if you're looking at things like traffic impact analysis and things like that. Yeah, so Bill, did you have something to say as well?
Actually, I was just going to mention one thing, which is you can, on the graphical reports, Levi, before you run the report, you can select whether you only wanted to show the little circle on the map, or if you also wanted to show your network. So click that and rerun it. It kind of looks nice in the graphics. I think if you if you show under the background instead of map without street names, if you pull that down, right there. Do map without street names or map with street names and network model without, second from the bottom.
Okay.
And then rerun it. And then let's look at the figures one more time, just to show the flexibility. And then after that, I think we'll move over to, after you show that, we can move over to Adam for any Q&As that we wanted to show. So that just shows the variation of how the graphic can look. Yeah.
Okay, so that is the conclusion